The Hürjet program itself was originally designed as a replacement for aging jet trainers, like the T-38 and F-5, used by many countries. However, as modern military needs evolve, jet trainers are no longer solely used for pilot training. This type of aircraft must also be capable of light combat missions, close air support, and border patrols. Composite materials have many advantages. In addition to being lighter, they also have high structural strength and are more corrosion-resistant. Carbon fiber sheets are cut using a high-precision, automated laser machine. Afterward, the material is placed into a giant mold and heated in a high-pressure autoclave. Entering the initial area of the production line, the first process begins with the fabrication of the fuselage structure. Unlike older jets, which used a large amount of conventional aluminum, the successor to the Hürjet is expected to use a much larger proportion of carbon composite materials. Throughout the production line, industrial robots work side by side with human technicians to assemble the Hürjet's fuselage. Robots are tasked with micro-drilling, automated riveting, and surface inspection using optical sensors. Meanwhile, human technicians are responsible for ensuring the final quality meets military aviation standards. The next stage is the integration of the wings with the fuselage. In modern fighter jets, wing design is not simply a lifting device, but a vital component that determines the aircraft's agility in dogfights. The aircraft uses an adaptive wing design with the latest generation of digital fly-by-wire controls. One of the most sterile and tightly guarded areas on the assembly line is the engine installation row. Modern jet engines are incredibly complex systems. Technicians then conduct a cold test, which involves testing the engine system without full combustion. After passing this stage, the engine is activated for its first live test, or engine run test. The engine is installed using a high-precision crane. Every fuel pipe connection, sensor cable, and hydraulic system are repeatedly checked. Even a small leak can cause a fatal failure during flight. If the engine is the heart of the aircraft, then the avionics are its brain. In the avionics integration room, hundreds of fiber optic cables and computer modules are precisely installed. New generation jets require enormous data processing capabilities. AESA radars, electro-optical sensors, electronic warfare systems, and satellite communications must operate simultaneously without interruption. Despite its status as a training jet, the Hürjet's successor is likely to possess serious combat capabilities. In the area of weapons integration, technicians have installed hardpoints under the wings and fuselage. These hardpoints allow the aircraft to carry a variety of weapons, including air-to-air missiles, smart bombs, reconnaissance pods, and even light anti-ship missiles. A modern targeting system allows pilots to strike targets with high accuracy from long range. Data link technology also allows the aircraft to share information with drones, ground radars, and other fighter aircraft in real time. The concept of modern warfare now places a heavy emphasis on connectivity. A jet no longer fights alone but is part of an interconnected digital combat network. Before leaving the hangar, each aircraft undergoes thousands of hours of testing. Hydraulic systems are pushed to their maximum limits. Simulations of electronic interference are conducted to test the resilience of the avionics. Test pilots then conduct taxi tests on the runway to ensure the aircraft's controls are working perfectly. Once all stages are passed, the aircraft makes its maiden flight. The moment of the first flight always symbolizes the success of the thousands of engineers, technicians, and workers involved in the project. The future of global attack trainer jets, the emergence of the Hürjet's successor, marks a major shift in the global military aerospace industry. Many countries are now seeking aircraft that are less expensive than heavy fighter jets, while still possessing modern combat capabilities. The next generation attack trainer jet is an ideal solution, capable of performing both functions simultaneously, training pilots, and conducting light combat operations at lower operational cost. In the future, such aircraft will likely work alongside autonomous combat drones. Human pilots will act as air commanders, while drones carry out high-risk missions. The assembly lines of next-generation aircraft will increasingly be filled with robotics, industrial AI, and data-driven digital manufacturing. But one thing remains constant. The world of aerospace still requires human creativity and precision to create the most advanced flying machines ever created. Behind every jet soaring through the skies are thousands of hands, millions of components, and an ever-evolving technological vision for the future of modern air warfare.